This set, known as the Type 144, marks a big step in ASDIC progress. Previous sets have only provided a plot of the range as it changes. The 144 plots the bearing as it changes as well. It consists of 3 units: the bearing recorder, an automatic control training unit, which includes a bearing repeater, and a range recorder. These are handled by 3 operators. The 2 recorders provide a visual record of the U-boat's whereabouts, and for a head-thrown attacks at any rate, the course to steer is calculated. Furthermore, the training of the oscillator is largely automatic. The working of the automatic control training unit is easily mastered and far simpler than the ordinary CTU. It is possible to do with it everything that was possible with the previous manual types. This is how it works. The top switch has 2 positions: continuous and auto. In the continuous train position, it causes the oscillator to revolve without stopping, as would be necessary for an HE listening watch. In the auto sweep position, the oscillator trains in steps. The size of the steps is controlled by the bottom switch, which again has 2 positions, one giving a 5-degree step angle, the other 2.5 degrees. What the oscillator is doing is shown by the repeater. This green pointer represents the oscillator. Here it is with the top switch at continuous, and here it is with the switch at auto. The direction in which it trains is governed by the circular training knob. This also acts as an on-off switch. Here it is in the off position, so whatever position the other switches are in, the oscillator won't do anything. In the position marked right cut on, the oscillator will move to the left, and in the position marked left cut on, it will move to the right. In other words, the direction required to find the cut on. But if the knob is pushed hard over on either side, it will cause the oscillator to turn continuously to that side. If an echo is heard, this push is pressed in order to plot the echo on the bearing recorder. If the middle step-back switch is on in the 2.5 degree and 5 degree position, pressing the echo push will also make the oscillator step back either 2.5 degrees or 5 degrees, according to the position of the bottom step angle switch. To demonstrate this, we'll put the echo push alongside the repeater. Press the push, back goes the oscillator, 5 degrees in this case because the step angle switch is set to 5 degrees. Then after one transmission it trains forward again automatically in the previous direction. To carry out sweeping procedure then, the top switch is set to auto and the step angle switch to 5 degrees. By holding the training knob hard over in the appropriate direction, the oscillator is brought round to the after bearing of one side of the sweep. Let go and the oscillator automatically trains back the opposite way in 5 degree steps. If the step-back switch, the middle one, is left in the on position, you won't have to waste time switching it on if a contact is picked up. When the oscillator reaches the dead ahead bearing, it is allowed to make one transmission 5 degrees beyond it. Then it is trained round to the after bearing of the opposite side of the sweep by holding the training knob hard over in the required direction. Release it, and of course the oscillator trains up in 5-degree steps to the right. When contact is made and holding procedure is to be followed, the echo push comes into use. The first time an echo is heard, the echo push is pressed and the oscillator steps back 5 degrees. If the transmission on that bearing is off target, the oscillator is allowed to train forward again, which it does of its own accord. The position of the after cut-on is established, and the oscillator is then allowed to step right across the target. The first transmission off target ranks as the forward cut-on. The oscillator is stepped back in 10-degree steps until no echo is heard, then allowed to train forward automatically again to record the after cut-on. Press the push, the oscillator steps back, then forward again across the target. This procedure continues until approach procedure is called for. Stepping the oscillator back in 10-degree steps is done, of course, by holding the training control hard over for the right length of time. For approach procedure, the step angle switch is set to 2.5 degrees. Cut-ons are then found in the following manner. The oscillator is allowed to train up in 2.5 degree steps until, say, the right cut-on is heard. The echo push is pressed and the oscillator steps back 2.5 degrees. It trains forward again and the right cut-on is plotted a second time. Then the oscillator is trained across the target and off the other side in one step. The operator should have a rough idea of extent of target. The oscillator is allowed to train back until the left cut-on is located. The echo push is pressed, the oscillator steps back, then trains forward again and the left cut-on is plotted a second time. Then across the target by holding the training control hard over to the right, and the whole thing is repeated. Each time the echo push is pressed, a mark is made on the bearing recorder paper. These marks represent the cut-ons, because the echo push is pressed only when each cut-on echo is heard. Thus, a double trace representing the extent of the target is formed on the paper. It is done by means of a series of styluses on a continuous band, which moves exactly as the oscillator moves, in the same direction and by the same amount. There is a bar marked off in degrees at the back, so that the bearing on which the oscillator is transmitting can be read off. The bar has 4 sides, and there are 2 sets of 4 styluses on the continuous band. The styluses are 90 degrees apart, but to avoid the chance of a trace forming so near the edge of the paper that it won't be readable, the width of the paper is taken to be 150 degrees, and each side of the bar is divided up into that number. Thus the whole 360 degrees of the compass is covered, with an overlap of 60 degrees between each side of the bar and the next. The ends of the bar are colored, each side differently, and each of the styluses in series is colored to correspond. Green, yellow, black, red. As the oscillator is trained to follow the target, the continuous band moves in step with it, and one or other of the styluses will be brought over the paper. Then, if the section of the bar with the same color is used, the bearing on which the oscillator is transmitting will be shown. On the front of the recorder is a carriage which can be moved along it by means of a handle at the back. It carries two lamp housings fitted with slotted masks through which the lamps shine down onto the paper, where they form two lines of light. These two lines of light must be lined up to the double trace, this adjustment on the front being provided to allow for variations in the extent of target. Attached to the carriage is a central pointer working over this scale. If the two lines of light are correctly lined up, this pointer will show the center bearing. This indicates the course to steer in the opening stages of the attack. But if the bearing is moving left or right, the trace will slope left or right. The amount of slope depends on the crossing speed, which in a head-thrown attack governs the amount of deflection which must be applied. So the light carriage can be swiveled, and the lines of light can thus be lined up to the sloping trace. A second pointer behind the first thus becomes offset. The amount by which it is offset is equivalent to the deflection required, and the bearing it shows becomes the course to steer, and also, of course, the gun bearing. There is no question of estimation or guesswork. It is done mathematically and instantaneously. This plate, which is on top of the bearing recorder, makes it possible to offset the deflection pointer by an amount corresponding to the attacking speed and sinking time in use. The normal setting for, say, a 9-knot ship and 7.5 seconds sinking time gives a reading of about 1. So the pointer on the scale alongside is set to 1 by means of the knob at the top. The setting on that scale controls the amount of deflection applied to the deflection pointer below. The speed of the paper drive in the bearing recorder increases as the range closes. A target crossing at long range has a lower rate of change of bearing than at firing range. If the bearing recorder paper speed were constant, the slope of the trace at long range would be different from the slope at firing range, and we should therefore have no advance information about deflection. Making the paper run slowly at long range and increasing its speed as range closes gives the trace a constant slope. Thus we know in advance what deflection is indicated, and any alteration in slope is entirely due to changes in the target's inclination, the range factor being eliminated. The increase is effected by a pulse unit. This is part of the bearing recorder, but it is actuated by contacts in the range recorder. The range recorder is a development of the AS3. It looks a pretty complicated instrument, but actually it's no more so than the old type. It has all the same features: stylus and range scales, scale 10, scale 25 knob, on-off switch, and here are the adjustment plates for ship speed and sinking time. This one for depth charge attacks, this one for head-thrown attacks. The adjustments are made by means of two knobs, this one for sinking time, and this one for ship speed. The usual firing bar is replaced by a line of light similar to those on the bearing recorder. It has the advantage that no parallax errors are possible with it. It can be lined up parallel to the echo trace in the ordinary way, the lamp housing being swiveled by a control at either end of the recorder. And this pointer indicates the relative speed on this scale. As you can see, 0 is in the middle, this part of the scale being provided to indicate the relative speed when the range is opening. The carriage can also be shifted along the range scale so that it can be brought down progressively as the range closes. The transmission interval is permanently fixed 300 yards above range. It is the movement of the carriage along the range scale which actuates the pulse unit in the bearing recorder and causes the speed of the bearing recorder paper to increase as the range decreases. So the line of light must be kept lined up accurately to the echo trace throughout the attack. On the carriage is a bar, and on the ship's speed sinking time assembly is a pin. These are electrical contacts. When firing range is reached, they will touch, and a circuit is thus completed which automatically sounds the firing buzzer at the weapon. The only remaining difference in this type of range recorder is that the paper has 3 speeds instead of 2. One very slow for cruising, which is brought into use by this knob, and the 2 normal attacking speeds for scale 25 and scale 10. You now know something about how the equipment works. Here is a demonstration of how it is used at sea. The operator is carrying out a routine sweep. The range recorder is running at cruising speed, and the paper is moving down very slowly. Things have been pretty uneventful up to now. He's picked up an echo, bearing 299. Change over to attacking speed, and bring the line of light down to the trace. Operator's off target at 304, which ranks as the right cut-on. Cuts back in 10-degree steps. Left cut-on is 292, which gives him a rough extent of 12 degrees. Bearings drawing left, so he classifies it as a submarine, and the captain decides to alter towards. Range 1600 yards. Range recorder number should take a check on his ship speed sinking time adjustments. There he goes. 7.5 seconds sinking time, and 9 knots called for. The bearing recorder number can't do very much at the moment because he's only getting 1 cut-on echo, remember. But he can at least bring his lines of light down to approximately the right place so that he's ready. The operator carries on holding procedure as the ship turns until the target is within 30 degrees of the bow, when he starts approach procedure. Watch that relative bearing. There he goes, step angle 2.5 degrees. Comes up for his left cut-on, which is 275. He gets it again. Then across the target to get the right cut on, which he'll be getting accurately for the first time, remember. And it turns out to be 282. And the captain steadies on 278, which is very close to the center bearing of the target. Now the bearing recorder number can line up his lines of light properly. He's getting 2 cut-ons recorded. There's the left cut-on 270. First operator gets it again. not satisfied with that one, he goes back for a third one. The bearing recorder number, in the meantime, lines up his left-hand line of light to that cut-on. Now he adjusts his extent of target to the right cut-on, which gives him an extent of approximately 5 degrees. Range 1500 yards. Now the range recorder number leaves his line of light at 1500 yards until the range is close to 900, because at that range he'll be changing into scale 10 and opening out. And with this machine it takes rather a long time to wind back from 900 in scale 25 to 900 in scale 10. If he leaves his line of light at 1500, it'll save a lot of time. Bearing still drawing left, ship's head's 275. In fact, the bearing's drawing so far left that the trace has nearly gone off the left-hand edge of the bearing recorder paper. So the operator changes over to the right-hand trace with the yellow stylus and the yellow face of the bar. Relative speed of approach, 10 knots. Now the ship's speed is 9 knots, we know that. So that means that the target's inclination is only very slight closing. In other words, the target's course is almost at right angles to the ship's course. You can see the deflection pointer shows something over 10 degrees, which is a fairly high rate of change of bearing. Now it's decreasing a bit, probably because the ship's altered course. Yes, he's steering 256, but by now the bearing recorder number should have reported recorder lined up, and the captain would have ordered steer by ASDIC. So the whole thing should be going on automatically. Deflection steadying somewhere around about 7 degrees. Range 900 yards into scale 10, and he opens out as quick as he can. Now you see why he left his line of light at 1500 yards, and he lines up to the new trace at about 830 yards. That heavy trace on the right of the echo trace is caused by the echo push circuit. The target's inclination is tending towards 90 degrees now, and you can see that the deflection pointer is offset by over 10 degrees. Now it's beginning to decrease, which means that the attacking ship's coming in astern of the submarine. And the relative speed of approach confirms that. It's dropped to 8 knots. Range 500 yards. The slope of the echo trace is straightening up a little bit. That's because the relative speed of approach has decreased, and the deflection is decreasing still more. The attacking ship's coming in on the submarine's quarter. It looks like being a stern chase. Range 300 yards. Those contacts are getting closer. Gun crew will be standing by, and the deflection is down to less than 5 degrees. It's a stern chase. Range 250 yards.